Yes, this is so easy. I love Deb. I love it.
Is it easier than a drawing?
Let's see here. I've got,
Every drawing is different.
let's look at 8. What are we going to do for 8? Okay? We know a couple of things. We know that this side is congruent to this side, right?
Yeah.
And we know that this side is congruent to this side, right? Okay? Now, if we were doing a proof, well, we know that because, well, they're equal. Definition of measurements equal, so definition of congruency, right? Okay? So technically, I'd be like, okay, BD is congruent to CE. That is a definition of congruent sides, of congruencies. Because they're equal, they're congruent. Right? BC is congruent to DE. Well, let's use a different color here. BC is congruent to DE. Same reason, right? Right? Because they're equal, right? So that would be called what? Definition of congruency, right? So then what? How do I know that DC is equal to DC? What's that called? Do you remember? Remember that rule?
Wait, what?
DC is congruent to DC or CD. You remember that rule? When you look in the mirror?
Reflection?
Yeah, reflexive is what we call it. Reflexive, right? So this is reflexive. Okay? Because it's the same line. It's the same line. Right? Because this is the same line, it has to be congruent to itself, doesn't it? Doesn't that make sense? Right? Alright. Then how do I know that the triangle, and this is the very important part, guys. What? How do I know that the triangle DBC, okay, is congruent, right? Is congruent to which triangle? If I'm saying DBC, if I'm going like this, DCBC, then how do I do this same one? CED, right? So we're saying CED. Notice we're doing the 3, the 4, and then the, I don't know what it is. But it's a 3, 4, 5 triangle. But we'll learn that later. Pythagorean theorem. Right? 3, 4, 5. Okay? So that means that it's going to be congruent to CED. Okay? So we should put these triangles out in front. Sorry about that. So triangle. And then they are congruent. Why do I know that they're congruent? What tells me that they are congruent? Huh? Come on, what rule? We have 5 rules. What are the 5 rules? Write them up here. Tell me what they are. 5 rules. Real quick. SSS. SAS. AAS. AS. Well, okay, but there's one before ASS. ASA. And then ASS only if it's right. And we also call it HL, right? So this one's kind of long, but whatever. Okay? Alright, so which one is this? What do you have? You have a side, you have a side, and you have a side. SSS. Okay? That's it. That's as easy as that. Okay? What about this one? First of all, these two sides are congruent, right? So that's a side and that's a side. Is that right? What is this? The An angle and an angle, right? And then are they sharing anything? Do they share a side? Do they share this? Right? So that means this side is congruent to itself, right? So that's another side. So what's that one called? What's it called? Side, angle, side. Remember, they have to be touching. They all have to be touching. Does that make sense? Okay? That's it. It's congruent because of side, angle, side. We don't have any letters, so we don't have to do a proof. Okay? So if you get one of these on your test and there's no letters, all I'm asking for is, tell me the proof. Is it angle, angle, side? Is it side, angle, side? Is it side, side, side? Is it angle, side, side? Or HL? Okay? That's it. Alright, 4.6. They're doing the same thing. Alright? So, they have, we know right now we have angles. Right? Do we have anything else on 11? Oops. No, we don't have anything else. So we have angles and we have a side, right? Go for it. So we know that we have an angle and a side. Is that enough?
No.
No. So we cannot prove it. Cannot prove. Okay? Cannot prove. Now, if, just because I want to be able to get a proof for you, okay? If I told you that this was congruent to this, what proof would that be now? What proof would that be? If I said that we have this side, this angle, and this side.
Side angle side?
Side angle side, right? Side angle side. Okay. What if I said you had this angle and this angle? Okay? Now what would you have?
Angle side angle?
Nope. Remember, they have to be touching.
Angle side?
So we know that we have angle, angle, side. Right? Because I'm skipping over this side and this angle to get to that, I can't go that way. I'm skipping over. Now I can skip over this to go to an angle because they're the next closest thing, right? But I can't skip over a side and an angle. Does that make sense? This is the hard part for students. Okay? They have to know that they have to go from here to here. They can do that. They can skip over this side, but they can't skip over a side and an angle. Okay? So we got angle, angle, side. Okay? So there's another way to find a proof. That's different from this. That's also different from this. Okay? Alright, next one. 16. We still haven't proved ASA. Okay, so what's this one? We know we have an angle, right? We know we have an angle, right? So we can say that angle A is congruent to angle, well, technically you would have to call this angle B, A, D, right? Is congruent to angle BCD. Okay? Definition of congruency, because they show that they're congruent, right? Then what can you show? So we know that's an angle. We have an angle. right? Okay, what else we got? We got another angle, right? Sorry, we have another angle
And this side.
and a side. Good. So this angle would be called what? B. BDA. BDA. Right? And that would be congruent to what? BDC.
C.
Okay? Why? Why? Definition of congruency. It says that they're congruent. Right? Alright. The hardest one. This side, right? What's this called when it's congruent to itself? When BD is congruent to DB. What's that called?
Reflexive.
Reflexive. Okay? Alright, so you have an angle. You have an angle. And you have a side. So what's the thing? So we have to name these in the correct order. Right? So how are we going to name this triangle? Triangle what? If I say ADB, what is that congruent to? How would I say this side? If I say ADB, then what do I got to say over here?
CDB.
CDB. Good.
I mean DDB.
CDB.
That's a B.
Right? Alright. And what are we going to do? What do we use?
Reflective.
No?
Congruent.
Definition of congruent.
No, guys. What are we learning here?
Oh,
AAS. You're learning those pieces. Okay? Last piece. Okay? If this is the midpoint, that means that these sides have to be congruent, right? If this is the midpoint, that means that these sides have to be congruent, right? So how do we know these two triangles are congruent? HL. Okay? You can go through the same method, but I know we're running out of time. Okay? But it's HL. Okay? Because you have a leg and you have a hypotenuse. You could also say what? If you prove that there's a right angle, you could also say angle side, side. Okay? Because it's right. Okay? Now the only one we didn't prove was what? Angle, side angle. So look up here. 1 second. If I want to prove this is angle side angle, then I would use angle side angle. Okay? Then I could have angle side angle. Does that make sense? Alright? So we didn't get to 4.7, but I will next period. But it's really easy because I know these are congruent because these pieces are congruent. If the triangles are congruent, then any piece in the triangle is congruent, right? CP, CTC. All right, see you after lunch.